Okay, so starting off with our essential question that we haven't talked about since learning proportions, how can we identify and represent proportional relationships? Start with identifying. How can we identify proportional relationships? What does proportion mean? Equal, okay. Identifying, if I pause. Identifying, we can look at it, see if they're equal. How can we represent proportions? How have we been writing them? What form have we been writing proportions in? What? What form are they in before that, though? Fractions. They're in fractions, okay? We write proportions as fractions. Thinking about similar, the difference between similar and congruent. What does similar mean? Alike, okay? What does congruent mean?
Different. Equal.
So similar, when you say alike, are they exactly the same?
Yes.
They're just similar to each other, they're not exactly the same. So congruent would be exactly the same. Okay? So if I had 5/10, would you agree that that's similar to 6/12? Why? They both get to 1/2 eventually, right? But are they exactly the same to each other? No, they're just similar because their proportions equal to 1/2. Okay, what would be something else that's similar to those two? What would be another example that's similar? 7/14? 8/16? Give me one more. One more other than Porter. 9/18 is one. Brayden, what's another one?
10 and 20. Brayden, 10 and 20.
60 and 120.
60 and 120. Awesome. All of those fractions or proportions are similar to each other because they all reduce down to 1/2. Okay? So we're going to be looking today at similar figures. We have these two shapes right here. Would you say those shapes are exactly the same? No, why not? One's bigger than the other. That's what makes them similar. Okay, they are the same shape, but they're different size. Okay, so if we talked about setting up proportions with these, if I had A, B, so I'm talking about this here, which side does that match on the other triangle? X and Y. We write those relationships on top of each other. Okay? Thinking about another relationship, if I had BC on the top, I'd have YZ on the bottom. Okay, the last one, if I had AC, that would match with XZ. Now, keep in mind, the fraction that we just came up with, that's the relationship between shape 1 and shape 2. Okay, so the top is always your shape 1. Top is always going to be shape 1. The bottom is always going to be shape 2. Now, if you put shape 2 on the top, that's okay. You just have to make sure you keep that shape on the top when you're setting these up. Okay? So the fraction or the ratio we come up with is the proportion between shape 1 and shape 2. Okay? Any questions over the model before we look at an example? All right, let's look at this example here. We have these two shapes. Would you say they are similar to each other? Why are they similar to each other? Same shape, but different size, okay? So we want to find out what this value of X is. We got to set up proportions first. I'm going to start with 4 centimeters right here. 4 centimeters over, now we have to match it with the other shape. Which one matches the 4 centimeters? Yep, 4 goes with 12, so 12 is going to go on the bottom. Equals, now we started with shape 1, or the shape on the left. We want to keep that one on the top. So what number do we have left for shape 1? 6 centimeters, and which one does that match with on the other one? X. Now we know how to solve these. How do I solve this to find the value of X? Cross multiply. I have 4 times X, 4X. I have 12 times 6, 72. What's my last step with these? Divide. Divide by 4. We get X equals 18.
18.
Any questions on the setup that we just set up? Okay, just remembering the fraction or the ratios you come up with, they're different shapes. Okay, and if you start with one shape on the top, you got to keep that one shape on the top the whole time. Okay? Go ahead and try these next two on your own. Set up the proportions and then solve for those. On A, what can be one ratio I can start with? 12 over 3. Okay, if you started with 3 over 12, that's totally okay too. Okay, I'm starting with 12 over 3. Since I started with 12 on the top, what number has to be on the top in the next one? 33. Same shape has to be on the top. Over, what does 33 match with? X. Did everyone get this setup? If you had it just flipped, that's okay too. As long as you have them lined up the same way.
I had 12 over 33.
Nope.
That's what I had.
Because remember, the ratio you make is the relationship between the two different shapes. Okay? Now if we solved this, what would we have?
8 times 25.
So going through that, we have 12 times x, which is 12x. 3 times 33 is 99. Last step, we do division. Divide by 12 on both sides. We get x equals 8.25. Any questions on that one? All right, let's set B up. If I start with 10, what number on the other shape goes with 10? 5. Equals, since I started with 10, what number do I have to start with on the other one? The same shape, 24 over x. Everyone okay with the setups? Okay, solving, we would have 10 times x, 10x, 24 times 5, 120. And then we divide by 10. We have x equals 12. Any questions on similar figures? Okay, I think the hardest part is just making sure we set them up correctly. Okay? All right. This example here, everyone set it up. I'll walk around and make sure we all set it up correctly. Okay, similar figures on B. If I start with 28 on my first shape, what one does that match with on the other shape? 4, right? Okay. Equals, since I started with the first shape, what do I have to start with on the second ratio? The same shape. What do I start with? 49 over D. Okay, let's solve 28 times D.
28D.
28D. We get 4 times
196.
49. 196. Okay, what's my last step? Divide by 28. D equals 7. Okay. Any other questions for me? All right.